Hello everyone and welcome to today's webinar with Recycleye. We are just going to wait a moment to let a couple more people join and then we'll get started. So thank you. Hello everyone again and welcome if you've just joined us. We are delighted to have you on today's webinar with Recycleye. We are ready to get started, so I will hand you over to our CEO, Victor de Wolf. Victor.
Thank you, Sarah. Thank you everyone for joining. So on the call with us, we have Rory Brien, General Manager of FCC RE3. He's based in Reading and manages the RE3 partnership for FCC. Him and his team have ensured that all systems in the plant work smoothly together. And Recycleye has been really fortunate to have him as one of our first customers. His pragmatic and hands-on approach has allowed us to develop a better solution and receive loads of feedback to build on future iterations. We also have Seb Millar, machine learning manager at Recycleye. He's the cornerstone behind the Recycleye system development. And prior to joining Recycleye, he led an R&D lab and has always been aware and excited of the latest research. I think he's the only person I know that follows tons of professors and PhDs on Twitter to make sure he knows within the day that their new research paper has been released. And we also have Zoe Cook, technical sales manager at Recycleye. Having visited more MRFs than she can probably count on her hands or count, has built up a tremendous experience in site operations and how automation can be sort of leveraged in sites. Now, the topics we'll cover today, we'll start with Seb kicking off and trying to bring some clarity behind the AI buzzwords, as well as some of the challenges associated with artificial intelligence. Rory will then share some of his experience automating his operations at FCC with Recycleye. And Zoe will close off sharing some really exciting information around an 18-month food and non-food grade sorting program we've been carrying in France. And of course, we'll wrap everything else with a webinar. But before we get started, for those that are not familiar with Recycleye, we're a team of 30 people today based in London as well as in France and Italy. We have spun out from Imperial College with a partnership with the world's second largest robot manufacturer, a company called Fanuc. Some of our backers include Microsoft, and we've also gotten a lot of funding from the European Union, as well as Innovate UK. And on our board, we have the likes of Bernard Rambier, the former Chief Executive Officer of Veolia. Today, we have clients and deployments everywhere from Northern Ireland, England, France, Italy, and Germany, and more recently, even Australia and the US. So let's get started. Seb is going to explain computer vision and its value to sorting. Seb, over to you.
Perfect. Thanks, Victor. So I wanted to tell you all a bit more about what we've learned rolling out our vision and robotic systems to waste facilities over mainly Europe. And to keep this concise, I want to mainly focus on the considerations that went into the vision system components. Some of it will dip into the robotics, but it's mainly going to be about the concepts of vision systems. So first up, I'd just like to clarify a few terms because there's plenty of buzzwords around the industry and they get confusing. So first up, we have the most general term, artificial intelligence. Now, as far as I can see, this seems to be applied just about anywhere. We have a computer system making decisions in a human-like manner. And this can be as simple as just some hardwired but sensible behavior, like turning lights off at night, something like that. I think partially because of the marketing associated with it, it gets somewhat overused. So the proof in the pudding is if times like the following are used. So next up, we have machine learning. Now this is a bit more of a specialized set of statistical tools mainly, and they're used in many industries. So we have financial forecasting, we have anomaly detection, we have weather modeling, we have all kinds of stuff. Machine learning is pretty general. Next, within machine learning, we have deep learning. Now these are a special class of models that mimic how the human brain is wired. Now, the analogy for using them that I like comes from Andrew Ng, who's an acclaimed scientist within the field. And he said, I think deep learning is akin to building a rocket ship. You need a huge engine and a lot of fuel. If you have a large engine and a tiny amount of fuel, you won't make it to orbit. If you have a tiny engine and a lot of fuel, you can't even lift off. To build a rocket, you need a huge engine and a lot of fuel. The analogy to deep learning is that the rocket engine are the deep learning models, and the fuel is the huge amounts of data that we feed these algorithms. So next up, we have computer vision, which is just the study of understanding images and videos. But in its full generality, this turns out to be really hard. So following the analogy, this is one of those fields that benefits from huge amounts of data and very clever models. So how is computer vision used? It's currently being used all around us in many situations, mainly because it's good at dealing with the very messy real world. So for example, we have traffic control recognition, we have crowd management, you can detect people in a crowd, track them, whatever. You can do text recognition in images. There's plenty of other examples, but here are a few that have automated real cities today. So how do we apply all this? Well, we can provide waste facilities with cheap, lightweight vision systems that they can retrofit into their plants and train models to detect waste. And here we see the output of the models on 3 different lines. So we've got an aluminium line on the left, a PET line in the middle, and a paper line on the right. Now, I just want to point out a few things about these predictions. So for each box that we predict, we also get a confidence. Now, this is the confidence that the model thinks that it is correct. And I'll touch on this point later, just because it's quite useful. We can do a lot of clever things with this. Also, because the models learn to see in a similar way to the human eye, as long as there's visually a difference and we have the data, we can train models to classify the waste. And that means that we're able to work with things like food grade versus non-food grade waste. We can do material type, we can do brand level, and here's just some examples of the flexibility of the system. Wonderful. So how did we do that? I mentioned before that you need a lot of data to train these models with any reasonable accuracy. So the first task for Recycleye was to try and get a lot of data. Now, unfortunately, there wasn't really a data set that existed for this. So we built one, and what we produced is called WasteNet. Now, we believe it's the world's largest open source data set of over 3 million images, and it's still growing as we're adding in more images from clients. We also have synthetic waste and we have brand level waste, and this has often been produced via our partnerships with Imperial College and TU Delft. So yeah. But that wasn't the end of what we needed to do. We needed to actually deploy these into real facilities and put them to work. And when we went about this, we immediately ran into some quite interesting problems. Now, first up, when we first deployed our models, we noticed that we were getting these tiny, really fast moving detections throughout the night, all apparently tissue paper, and it was just buzzing about. And when we looked back through it, of course, we just saw that, you're going to a waste facility, which is smelly and full of waste. And so there's flies everywhere. And it turns out that throughout the night, every so often, one of these would be detected as a fly. So we wanted reporting accurately for clients. And so we needed some way of throwing away these detections. And one thing that we found that worked quite well was to exploit the fact that we don't want any detections when the belt isn't moving. So we built out a module within our vision system that just tries to predict frame-to-frame movement within the image. And if it can't see the whole belt moving, then it just discards all detections. And that got rid of that problem, which quite neatly wrap that up. Second up, still on an animal theme, we had a situation where we'd started recording images regularly whenever we detected anything. And we checked back over Christmas break, expecting to see a whole load of new data come in. And the first thing that we saw was this little picture of this cat snuggled up on this belt. Now, what we have deduced has happened was a lonely cat walking around over Christmas break, looking for somewhere cozy to sit. And it wanders into this waste facility and finds the one light still left on, and it snuggles up under it, as cats are wont to do, giving us plenty of pictures for our informal MLT mascot. Finally, we have our local celebrations and habits. Now, this is an interesting situation where obviously our models are only as good as the data you feed it. And this became a relevant issue when we deployed to our first aluminium line model, and it was in Northern Ireland. And we'd done a scan, we tested it, and we found that it was only really working on a subset of the data. And when we looked at it, it was only really doing anything sensible on Guinness cans. And so we went back to the data to try and figure out what was going on. And it turns out that we'd accidentally scheduled the scan for the week following St. Patrick's Day. And so almost all of the cans on the belt were just Guinness cans. And so our model was only really good at detecting these. Now, what we needed to do was just, do another scan a month later, and that kind of evened things out. But still to this day, our aluminium models are slightly better at Guinness cans than they really should be. So we've deployed our systems, we've got that working, and now we can start to see the benefits of it. So here we have a little table comparing some of the trade-offs between other sorting systems within facilities. Now, first up, we have human sorters, which are high quality, expensive, needs maintenance, and whilst they're good at sorting, you can't get the large-scale live granular reporting from them. We also see comparisons to near-infrared, which whilst reliable, is very, very expensive hardware. Now, the nice thing about our AI is now that we've made WasteNet and we've trained the models, we just need a webcam. So it's actually pretty cheap per unit to roll out. And because it's so flexible at detecting anything that you train the models on, we can get material level, we get brand level, we get item level. There's no real limitation within the technology to that, whether it is in near infrared. Wonderful. So I'd like to, we made all of this and then we applied it to some robots. And I just want to talk briefly about that process. So when we applied it, we were able to achieve pick rates of above 50 picks per minute on all of our lines and providing solid output purities. At this point, I'd like to add a little bit of nuance onto these numbers and some considerations that went into them. Now, when reporting, most of the industry works off of the pure metric of picks per minute. However, when we deployed our robots, we found that optimizing only this wasn't quite what we actually needed. So we were there making a prioritization scheme for the robot, trying to tell it what it should pick when. And the fastest thing to do was always just pick the first available item, because this minimizes downtime and so increases our pick rate that we managed to report. However, when we were working on lines such as this one, we found that we had a wide range of added value per pick. So I just want everyone to take a look at this image and see that we've got some shredded paper, we've got some tissue paper, we've got PET tray, and then we've got those nice big juicy HDPE NAT on the right. And so when we're picking on this line, we find that if we just picked the first one, when you get shredded paper, there tends to be loads of them. So just because there's so many, often that ended up being first in the priority. So we needed some way of prioritizing the actually valuable items, because it wasn't really adding much to pick all of this really light stuff. So what we did was we implemented a system that first prioritized the classes. So HDPE NAT being worth plenty of money is obviously the first thing that we pick. And also then we prioritize the large items first. And so from this, we still managed to achieve pick rates of over 50. However, it was suddenly worth so much more to our clients. The next thing I wanted to touch on is why not use accuracy as a metric. Now, whilst this is a much more common metric within the industry, I just want to point out why it doesn't paint such a full picture for waste detection. Now, the first point is that accuracy is the relevant metric when you absolutely know that you're looking at exactly one object and you're just determining how often your system classifies it correctly. However, waste is very often piled up, as we see here, for example, on this front end line. And so it's not really that obvious for an algorithm to tell where one object starts and another one ends. And I think that's reasonable. Looking at this image, it's kind of tough to tell, like to pick out each individual bit of paper, for example. So to improve on this, we commonly work with purity and efficiency. Purity is just how accurate we are on the objects that we detect, and efficiency tracks how many objects we are correctly identifying. Now, an important point about these metrics is that we operate with a trade-off between the two. Earlier, I mentioned that the models identify each object along with the confidence that it's correct. Now, we can choose to only accept predictions made above a certain confidence threshold. And by varying this, for example, increasing it, we can accept only the very confident predictions, thereby increasing the purity, but decreasing the efficiency. And when we look at all of the different confidences that we can plot, we get one of these curves. So you can see that at high confidences, we're in this kind of top left region where you're very pure, but maybe you don't have such great efficiency, i.e. you're not picking as much. And if we drop the confidence, then we get a nice curve as it goes around to lower purity, but getting basically everything on the belt. And so what we do is we generate these plots for each client and we just talk them through where they are on the curve. We get this per class and we talk through what's possible for their needs. For example, if they need 97% purity, then we can up that and lower the efficiency, perhaps, whatever works. Wonderful. So just to summarize, the key points I want you to take home: computer vision's everywhere, but not particularly easy. So we developed WasteNet to train very clever algorithms on cheap hardware, which now keeps the cost per unit low, whilst having plenty of benefits. Moreover, there are plenty of ways that we've found that we can add value that go past the industry standard metrics. We found these just by working with waste for a long time. To find, for example, that the picks per minute isn't quite the only metric that matters when considering robots, and also that these purity efficiency trade-offs can add a lot of value to your output streams. That's all I wanted to say to you all today. Over to Victor and Rory.
Thank you, Seb. So in September of 2021, Rory worked with us to install the first retrofittable AI-powered robotic waste picking system in England. FCC RE3 took the decision to install a Recycleye robotic unit on their HDP QC line, where the main target was the quality control of the HDP natural, but it is a split belt and any extra available picks are being used to quality control the mixed plastics that runs alongside it, on top of then picking out material in 4 separate buckets: fiber, residuals, cans, and film. Rory, welcome. It's lovely to have you with us. How are you today?
Brilliant. Thanks, Victor. Yeah, really good, and really happy to be here and be part of this.
Great. Well, I'd love to cover the drivers that made you decide to invest in robotic sorting and the journey that you've been along with us and the team. So we'll jump straight into it. As general manager of FCC RE3, could you share what your responsibilities are with regards to strategic and operational decisions?
Okay, so, not only am I responsible for delivering our current services, it's about developing the strategies on how we're going to future-proof them, how we're going to develop our partnership with the councils, which obviously includes technology. It's about working with them, making sure that we deliver the frontline services and that they're adaptable, that we can future-proof, and of course, increasing our recycling diversion performance and minimising environmental impact.
Okay, thanks. And what are your initial sort of objectives when you considered robotic automation in the first place?
Well, I think one of the things, for FCC and the RE3 partnership is, we're very forward thinking. We're always looking, at new technologies and ones that we can adapt. Particularly interested in technologies that can improve the recycling process. And one of our main drivers was about ensuring that we have good material purity, which again helps us get sustainable offtake, future-proof that. And if I look back at my now 10 years with FCC, my previous role as general manager for the trading team, which I used to market all of our recyclates, for me, I really see the relevance, and the importance of having that good quality material output from the MRF, and you kind of pull all of this together with the capabilities of the robot, and it helps us push and develop that sustainable growth of the business.
Okay, and could you share a bit more information on what line the system was deployed on and how that decision was made to select that site?
So I think, one of the things which was really good was obviously when we met with you, you and your team came out to the MRF, we'd done a good walk round, a good investigation as to where we thought it would get the best results, and identifying the plastics line was where we thought we'd get, really good results. I think as you picked up and mentioned earlier, the robot is actually doing quite a lot of work in that plastics cabin. It's a split stream line of plastic that comes in. So the main focus for the robot is ensuring that the HD Natural is placed on one side of the belt. Then making sure that that's free of contamination, removing things such as fibre contamination, making sure the other mixed plastics are on the other side of the belt. So I think we saw the real value in what that could do in that particular cabin.
Okay, and had you tried automation at your site before?
We've got automation, but this is the first time we've ever tested robotic picking, so that's why for us this was really exciting, because it's the first time across our UK business that we've done it.
Okay, and how easy was it to get approval for the project?
I think one of the things that enabled me to get the approval was being able to go to the board with the data and the information provided by yourselves, particularly that was demonstrated the increase in performance, which obviously drives financial benefits. And I think one of the other key things was how this aligns with our company value of being forward thinking, and actually, that our overall strategy of being ready for the future and being prepared for that, and we felt that this technology would help us, do that and be relevant now as well as being able to adapt for the future.
Okay, could you perhaps talk the audience through how the installation went for you?
Yeah, so the installation was really good. There's obviously a lot of work leading up to that, in terms of planning and design, and and the Recycleye team were able to work with our site team and our FCC engineering team to work on that. The install itself went really well. It was done over a weekend, so no disruption to the operation of the MRF, which was absolutely fantastic. There's a small team of Recycleye people that were there. And because of the way it was planned and the way you delivered it, it was all of the robot, the frame, the safety equipment, the cage was able to be built within the MRF cabin. So, again, no heavy lifting equipment, no big interruption to all the other operations on the site. So from our point of view, that went really well.
Okay, and could you perhaps share what the process after the initial installation was like?
Yeah, so again, the Recycleye team worked with our FCC engineering team, not only to make sure that the install went well and then the implementation, but then again, what I thought was really good, the way that everyone worked as a team, the Recycleye team, the FCC engineering team, and my site team in particular, Laura Fisher, one of my colleagues, we were able to really kind of identify improvements to the robot, implement changes, which has helped improve the accuracy and the performance. So yeah, a really great team effort working forward.
Okay, great. And what results have you seen?
Well, there's some great results at the moment, and obviously, some of them are in the case study that will be provided. But I think, we're now achieving sort of up to 55 picks per minute, which is really fantastic. One of the big things for us, is the material quality. So if we look at our HDPE natural, less than 1% contamination within that going out. So, that's brilliant, absolutely great performance. And what we've been able to do is analyze that data with yourselves. We've seen over the period the robot's been in, we've seen a 12% increase, in the target material that's been picked. So yeah, fantastic results so far, getting better and better.
Okay, and how do you know that those results are indeed accurate?
So the dashboard that is provided by Recycleye, really good, contains some really good information. So we can look at things like, the amount of items on the belt, the amount of picks that the robot has undertaken, what those picks were, what material type it was, where it placed those materials, was it on the correct side of the belt, was it in the correct chute? We're then able to, we can then perform some manual checks. So we can do some physical checks on the sample data of the material outputs, so we can verify that those numbers are accurate.
Okay, great. And would you consider more robots?
Well, I think, of course, we'd love to look and develop, and we're already exploring potential opportunities elsewhere within FCC. But I think for us, we see the time to invest in technology and equipment is now. But what I would say, it's absolutely vital that we get clarification from the government on their consultations for DRS, consistent collections, because what will that enable us to do? We can then really assess and target the investment that we need to make sure that we are putting the right equipment that's not only relevant now, but relevant for the future as well. Okay, great.
And what's next for you?
Well, I think, picking up on what we've been saying, obviously being forward thinking, we're always concentrating on the future, what it'll bring. We're looking at the potential new materials such as flexi plastics, those sorts of things. It's about working with our local authorities to make sure that they're able to adapt and be ready for the potential changes from the resource and waste strategy. How do we develop our frontline services? What technology we're going to use for that? And yeah. Let's hope it'd be really great if we could develop more robotics and continue our partnership together.
Great. Well, Rory, thank you so much for being with us today and taking the time. I'd love to remind all the attendees that if you do have any questions, please do already submit them into the Q&A section, which you should sort of access probably top right of the Teams tab. And we'll make sure we answer those once we come to the questions. But before we move on to that, up next, Zoe will be presenting this amazing case study of food and non-food grade plastic sorting that Recycleye has been involved in. Zoe, over to you.
Thanks, Victor. Yeah, so as Victor said, I wanted to introduce a project to you that we're really excited about here at Recycleye. In a world first, we've spent the last 18 months developing sorting technology for food and non-food grade polymers. It's part of an R&D project with Citeo, who are the French equivalent of RAP, and we've partnered with Valaplast and Total to detect and separate food grade PP. This is really exciting as it can ensure that food grade plastics are kept in circulation. In the UK, this kind of grading of polymers can actually sell for up to 4 times the amount of their mixed grade, depending on the specific market, of course. So the potential added value for MRFs in separating them is therefore really high. Interestingly, this project has had a 500 kilos of sample waste from 5 different facilities across regions of France. What this means is it's a much better representation of French waste than if we worked with just the one facility. It means that the results that we've hit so far are really promising for a lot more future applications. There were 3 key objectives behind this project, with the first being to validate that the vision system is indeed capable of detecting between food and non-food grade PP and can thus be used for assuring quality of the outflow. And then the capacity of integrating this detection with mechanical sorting, i.e. our robotic arm, to validate the efficiency of separating food grade PP. The end goal of the project is to create a market where food grade PP can be recycled into high performance polymers and sold as containers for food items. We're currently actually working with the European Food Safety Authority to get approval for food grade plastics and start creating this new high quality PP market. We've had some really pleasing results to date. The aim of the project was to positively pick the food grade PP, and as Seb explained to us, when extracting materials from a line, we do have to make a trade-off between high purity and high efficiency. In this case, high precision resulting in high purity of the food grade materials was chosen. The reasoning behind this is that minimal mistakes on picking the food grade PP and therefore having very little non-food grade polymers in that outflow was deemed really important in being able to sell it on and recycle it as truly food grade polymers. This was deemed more vital than recovering any potential revenue through food grade PP lost to the non-food grade stream. The results have hit an impressive 97.2% purity so far and a recall of over 50%. What this means is that over half of the food grade material has actually been removed. Wider than just PP, we're seeing a big trend for increased demand in food versus non-food grade polymer sorting, and predict this to increasingly be the case in the future. We've run quite a few other demos now on different plastic classes. With PET on an incoming stream of 90% purity, we've been able to increase that to a 95% outflow. With a HDP stream of 92% food grade purity, we've achieved 97%. With such promising results, the future of food grade plastic recycling really does have a lot of potential. Yeah, so I'll hand back over to Victor for a brief summary of what we've covered. Victor?
Great, thank you, Zoe. So just to sum up what we've covered today, we had Seb talk about a lot of the engineering and all the hard work that needs to go behind the AI to make it work. But now that it's working well, we can see how it can be used to move towards 100% tracking within sampling and to provide all of that data. Robots have been redesigned to reduce maintenance costs. We've seen how Rory, is using them 24/7 to increase, performance, reliability, and using them very consistently. It allows to reduce hiring costs by up to 3.6 million per year for a whole plant if it's fully automated, as well as to redeploy staff elsewhere in a facility and really solve that labor shortage that we've seen many of our clients face. We've also seen how AI is starting to be used in food grade sorting application and critically without the need of any watermarkers. So this technology can be used today, although we are of course working with EFSA to make sure we have all the regulatory approval to do so beyond the technical capabilities, and how that supports higher resale values for target materials. So I believe we'll move on to the Q&A. I'll hand over back to Sarah to moderate any of the questions.
Thanks, Victor. Yes, we've had some great questions come through. So just going from the top, the first one is from Phil. Have you found that the machines find it difficult to identify black plastics? Who would like to answer that question?
I can take this one. Well, actually, Seb, you're probably in a better place than me on that. Go for it.
Yeah. It can be difficult to identify, particularly if it's black on a black conveyor belt. So as long as the lighting is okay and we have enough data, it tends to work out fine. As I said, it works based on the same methods as the human eye. So as long as you can see it in a video and we can adjust our lights to deal with this problem, then yeah, we can work with this fine.
Yeah. Just to add my 2 cents, compared to near infrared, we've had very, very high reliabilities on black plastics. One of the lines we've had a lot was on an aluminium line recently, and pretty much every single one of them gets detected. The only caveat, however, is once we are able to detect the black plastics, we can't necessarily detect which type of plastic the black item is.
Okay, lovely. Thank you both. The next one starts with a very nice comment about the work. Thank you. I think this is one for Seb. Have you considered combining hyperspectral with machine learning / computer vision to increase the performance for material discrimination?
Yes, I absolutely have. I have dreams too. That would be amazing. We do want to keep the cost per unit down for now, but I'll leave Victor to talk more on this.
Yeah, I think I see sensing as 3 distinct parts. middle part is where both near infrared and AI can do it. That can be your paper line, your plastic lines. Then there's this whole part where only AI can do it. That's aluminium lines, sorting out cans versus aluminium foils versus aluminium trays. But of course, there's still a chunk where only near infrared can do the sensing. And let's say a white PE pod versus white PP pod. There's no way AI is ever going to know the difference. So we don't see ourselves replacing near infrared anytime soon, and so we see most facilities actually having both types of sensors are going to lead to significantly more robust systems. But albeit today Recycleye's focus is purely on the AI, because it does also allow to have a much more affordable system. As soon as we add other sensors, it changes quite a bit. And so yeah, the company's focus today is just the artificial intelligence and all the software that powers it.
Perfect. Thank you, Victor. I think the next one is for you. Is there a reason that a robot is better than the more typically used air blowers for sorting lightweight materials?
Yes, there is. So they have, again, it's always advantages and disadvantages of each. The advantage of the robot is it's significantly more targeted. So an air blower is very good at doing high rate, but it's always going to have sort of an air jet off shot. So for smaller items, it's probably going to get some more items than you otherwise might want to shoot out, say particularly on a paper line. And so the robot is significantly more targeted. Similarly, it also has a higher load carrying capacity. So water bottles that might be a bit filled, you're able to pick it up more easily. And lastly, in a lot of those final quality control stages, an air blower wouldn't be suitable because you don't necessarily sort into 2 categories. In the QC bin, you typically sort out into sort of up to 4 categories. In this scenario with the FCC project, we're sorting into 4 different categories plus toggling between 2 belts, the split belt. And an air blower just wouldn't have that. It could only do 2, well, sort into 1 bin and leave on the belt. And so that's one of the main advantages of the robot over the air blowers.
Lovely, thanks, Victor. The next question is from Phil. How accurately can this system sort plastics into respective resin codes, etc.?
Seb, do you want to take that one?
I just want to clarify, is the resin code like the number on the bottom?
Yeah, so that would be like PT versus HDP, I think.
Yeah, so this is a pretty core part of the things that we need to sort. For example, the application at FCC was an HDPE primary line, and one of the bins output was other plastics that are still valuable. So one thing that we did was we made sure that we understood exactly how to tell the difference visually between them. This involved me in the kitchen going through my recycling with a hammer, trying to figure out how it breaks up. Because they tear differently, and these are the things that the vision system can pick up on. Made sure our data quality was labeled to this standard, and then trained the models, and the results kind of spoke for themselves.
Lovely, thank you. The next one I think is probably one for you, Victor. Who makes sure your robot keeps working effectively? What support does it come with?
Our team does. So we've developed a huge after-sales network that has several levels. So level number 1 is a software layer, which has alerts. So for example, in FCC's robot, we have a pressure sensor that knows immediately when there's a failed pick. If we have more than a number of certain failed picks, we know when the robot is down, we're aware, and we've added sort of remote cameras that we can sort of dial into to see exactly what's happening with the robot and merge them with the exact timestamp of the vision system to troubleshoot any problems. Today, we have a sort of a maintenance team, so we can sort of come to site quite rapidly. On top of that, through our partnership with FANUC, we have access to all of their maintenance engineers in Europe. And so they come as sort of that extra layer. So it's the software, our team, and then the sort of FANUC team that can also come and support. We provide clients with tons of spare parts. We do sort of basic training to replace any parts, such as the grippers, etc. And we're also available via we have sort of a WhatsApp number that any clients can sort of message directly to get any support.
Lovely, thank you. Next one's a great question. Could you say more about how robots ID visually food grade versus non-food grade, please? E.g., is it recognizable? Is it recognizing the brand shapes or something more technical?
Let Seb jump in, but there is a lot of sensitive information there. But yeah, or Seb answer, but if you can answer it on a high level, because that was a lot of work we did in-house.
Yes. So on a high level, mostly yes. However, the devil's in the details. So you can imagine easy things to tell the difference is if it's detergent. There's very recognizable brands, shapes, etc. Then there's the kind of fine-grained ones, which are a bit more difficult. Like if you've got a plain white bucket, what was the they are often like industrial food supplies for restaurants, come in the same buckets that paint comes in. And obviously you don't want to get those confused. And those are a bit more tricky, and I will leave ambiguous up to your imagination how we deal with those.
Thank you, Seb. The next question, I think, is one for you, Victor. Are you looking at applications outside of the MRF?
Yes, we are. So we have, I guess, two main fields of that. Number one is we have clients that are interested in what's called the mini MRF, which is sort of, they have some, essentially the whole idea is having a small local sorting center to extract all the high value material in sort of, so they avoid transport cost of having trucks go far outside your city center. And we've just done our first deployment in Paris. That's a small site in the center of Paris that collects loads of waste from the local train stations. Before, they used to sort it manually, have sort of 10 people on the table, open a bag, sort it out into 5 different categories. And now they've operated it with our system, so building a mini MRF. And now we're also working with several airports that are interested in doing the same and managing some of their own waste. And of course, outside the MRF, we are getting loads of requests for applications such as construction demolition, waste, sort of metal sorting. We're exploring them at the moment, but of course, again, as a startup, we can't do everything. So we are focusing on the MRF for the time being. But from a vision perspective, there's not a big difference of going from, say, an HDP line to a paper line. To go from an HDP line to a concrete line or to a metal line, all the infrastructure we've built up is going to be applicable to all these other applications as well.
Fantastic, thank you. We just got 2 more questions. So if anybody does want to squeeze in one last question, now is the time. I think you may have answered the next one, Victor. What materials other than plastic can be identified by computer vision?
The real rule of thumb here is if a human is able to identify those materials, so will the AI. If a human cannot, and that can be a well-trained human, if a well-trained human cannot identify those materials, then the AI will not, and then you need another type of sensor.
Perfect, thank you. And then the last question I think is definitely one for you. Are you working with manufacturers to improve recyclability of problematic containers? How about barcodes on containers?
We are working with manufacturers in some capacity, not on necessarily changing their packaging, but they're providing some support to improve the recycling systems in the MRFs to sort out some of their existing packages. Though we're still very much open to speak to any new manufacturers and share sort of our views on what they can do to make their products easier to recycle.
Fantastic, thank you. Okay, so that is all the questions that we've been asked. I'll just wait just a moment just to see if anyone else has another one that they want to submit. Nothing coming through. Okay, so I think it's time to say thank you very much to everyone for attending today. We will share a copy of the slides and a recording of the webinar, and we'll also share a copy of the case study we've written with FCC RE3 on the work that we did with Rory and his team. Thank you so much to our special guest Rory Brien from FCC and all of our Recycleye presenters, and to all of you for joining us today. We'll see you on our next webinar. Thank you.
Thank you very much.